Hello everybody, welcome to the Ceph Developer Monthly for February 2018. Today Leo is doing a Ceph Day in Germany, so he won't be around, and Sage is going to be running a bit late, so he may show up a little later. I think we have got enough folks to start out now though, so it looks like the first topic is Dashboard V2. Is someone here who wanted to discuss that?
Yeah. I
Take
would
it away,
like to
Sebastian.
present that. Okay, maybe if I can share my screen, maybe it works. No, it won't that easy. Okay, then just a voice. Yeah, our idea is to build a fully fledged management UI as part of the Ceph Manager. The team behind is the Openmatic team from SUSE, and we are currently building a dashboard version 2 that will be the successor of the existing dashboard. Yeah, our goal is, or our first milestone is to get on par with the existing dashboard by using some code from the existing dashboard backend code and also some code of the front end. But we're also using some Openmatic backend code and front end code. The front end will be in Angular.js. No, in Angular 2. Sorry. And the backend will be very similar to the existing dashboard in Python with CherryPy that's loaded into the manager. So the current status is that we have on the backend side, the groundwork work is done. So we are just implementing or copying features or copying code from the existing dashboard, as I said, to get on par with the existing dashboard. And from the front end side, we are doing some groundwork and working on the health page on the dashboard and the other pages. We have opened a pull request. Can share the link, hopefully. No, I will send it later after a few seconds. Yeah, I can also share some screenshots. I will just send a link to the chat. Yeah, and our next goal is to get something that can at least be reviewed by the end of next week. And yeah, the pull request that we have opened and that everyone can have a look at is this one here. And also share some links to some existing work in progress screenshots. Currently merged is not that much, but we have plenty of open pull requests right now. The development takes place on a fork of the Ceph repository in the Openmatic project. And yeah, that's all I wanted to share. Questions?
really good with the screenshots. So I guess once it's, are you planning to have all the same functionality then in the pull request for next week?
Yeah, that's at least the current plan, to have something for end of next week.
Excellent.
We aim for that.
I have a question on is OpenAttic, are you using the salt stack for communication between the nodes, the salt minions and the what was the other daemon that runs the diamond daemon on the nodes? Because I know OpenAttic and the SUSE deployment and tools are based on the salt stack.
Yeah.
We've been using them, and currently we do our deployments using Ansible. So we
right now we don't want to integrate any integration with SaltStack or Ansible. We just want to concentrate on everything that's available from within the manager or existing libraries.
So then what? Okay, so then, well, I don't know enough about OpenAttic to speak overly detailed, other than I know I've worked with the salt stack before, back in the Calamari days, and I know we've been looking. Our organization has been looking at OpenAttic, and we use SUSE. So we're just curious about salt stack. I mean, I don't see why you couldn't deploy with Ansible and have it deploy the salt stack components if that was required. But
yeah, everything that we do in the upstream Ceph project for the moment will be without any integration of Ansible or SaltStack. Right now, within SUSE, we will of course also have a look at integrating the existing OpenAttic SaltStack functionality.
So I'm also curious about the monitoring piece of this. How is that going to be integrated or how are you thinking about integrating that?
Yeah, right now OpenAttic as a standalone project has a way to integrate the a Grafana dashboard, and we would like to provide a similar integration of a Grafana dashboard, but as we don't want to integrate with any deployment tools, EU has to manually set up a Grafana proxy, for example, and configure the dashboard version 2 to integrate that dashboard. But that's up to a deployment tool to automate that.
Got it. Okay. So you can have kind of an arbitrary storage backend for the metrics data somewhere that's with the dashboard displaying it. Your proxy, or how does that work?
Yeah, that's more of a reverse proxy where we just forward requests to the Grafana dashboard, and we don't care exactly how the how Grafana is configured, but we are shipping some predefined dashboards for Grafana. So we expect that some metrics are there. But in general, we will just integrate the existing dashboard.
Okay, cool. Yeah, that makes sense. So what are the plans after next week?
Yeah, we would like to get our pull requests then merged, of course, and then continue to work on pull requests that directly can be merged into the master. And then, of course, we would like to get to a point where we can also get on par with OpenAttic, for example, but that's not decided. It depends on how far we can get.
Sure. So what are the kind of gaps between OpenAttic and then the existing dashboard then that you're looking to fill?
The
Is
existing
this still like
dashboard,
what's described in this Etherpad there?
the existing dashboard right now doesn't have management functionalities. It only basically displays data.
Mhm.
And yeah, OpenAttic from the beginning on also provide management functionality, for example, creating pools. And yeah, that was one of our main goals, to provide that. And using, for example, Angular as a framework for the user interface.
Got it. Okay. Yeah, sorry for the basic questions, but I haven't really been looking into the dashboard stuff at all myself. So all right.
Yeah, and on
Any other
OpenAttic,
questions?
on
Yeah.
openattic.org, we of course have some information about the existing OpenAttic. But the dashboard version 2 won't be OpenAttic, but it will be some kind of merge of the existing dashboard and some existing OpenAttic code and some new code. So it will be kind of a merge.
All right. Any other questions about the dashboard? Okay. Well, thanks, Sebastian. Looking forward to seeing the full PR next week.
Yeah, thanks for letting me present it.
So I guess next on the list is Messenger v2 and transport encryption. I guess Sage would want to talk about this. Maybe we should wait for Sage to be here, or Ricardo, do you want to speak to this first, or?
Let's wait for Sage.
Okay.
Then, yeah.
In that case, the next one would be tracker issue regarding the MDS lock sync mix state. Juhan, do you want to talk about this?
Excuse me. Can you hear me?
Yeah.
Yes.
Sorry. Okay. Start sharing my screen. Okay. Can you see my screen now? Yes.
Mm-hmm.
Okay. The problem is like this. Recently, we've seen in our online clusters, Luminous clusters, that there are occasionally a lot of slow requests like this, and our use case is like this. We have one writing client that keep copying files into a directory, and tens of other clients issue reads and start operations to those files. And after we discover these slow requests, we did some testing and analysis, and the results shows like this. First is that almost all the slow requests are get ATTR requests, and they're all blocked by this state. This should be a log sync mix state, and if we go into these logs, and we can see that nearly for every get attribute operation, there could be the following situation is one get attribute operation would call this scatter mix method and make the inodes file lock into the log sync mix state, and in this state it will have to wait for all the issue caps to be allowed, and wait for all those not allowed issued caps to be revoked, and this procedure could last for almost 1 second, and after that, sorry. Okay. And after when all the unallowed caps are revoked, and the file lock goes into mix state, this block mix state, and however, if after the file lock goes into lock mix state, and the next request to be processed is still a get attribute operation, which will make will again the file lock state from block mix to a lock sync, and again it will issue these caps like as FSC to all the reading clients, and again, and when the next get attribute operation to be processed, and it will make the file lock again goes into the lock sync mix state, and keep repeating this, and the result is for every for every second, nearly only one get attribute operation can be processed, and the writing client is almost blocked forever. The situation is like this. I don't know if I'm making myself clear. Hi.
Yeah, I think that's pretty clear. Patrick, maybe you have some ideas about this?
So this is with the issue where the get atters are blocking for about a second. Is that correct?
Not really. Since there are lots of get ATTR, get attribute operations, the process, the response time for the process of get attribute operation could be tens of seconds. In our test, it lasts for nearly 40 seconds, and the writing is it seems not done. It's blocked for nearly an hour until sometimes until the reading all finished, and then the write gets processed.
Okay, that definitely sounds like a bug.
And since
We have an issue for that, I think, right?
Yeah, this issue. Yeah, this issue. And we, although we know what caused the problem, but since we haven't fully understand the design of those capabilities, and we actually don't know what to do with it. And so I'm here searching for help.
Yeah, we'll definitely need to take this discussion offline. We'll have to work with Jung to see how we can improve this.
Okay.
I don't have any particular ideas on how to resolve this issue.
Okay. Thank you. I think maybe make
Shuehan, I think we lost your audio for a while.
Yeah.
Can you repeat what you just said?
Okay, can you hear me now?
Yeah.
Can you hear me now? Oh, sorry. We think maybe making the MTS wait for all the reading clients to release their unallowed caps seems not very parallelized. I think maybe we can parallelize this procedure and somehow, but also I don't have any particular ideas. I think that's all for this issue.
Okay. Well, it sounds like we need to discuss that more offline with more folks. So, Shuhan, do you want to continue on with the next topic? There's the replication.
Yeah. That's the next section is again greatest level replication. This has been. I have to apologize for not responding to this topic for so long. I was appointed to some other work and didn't have much time considering this. And until recently, I got some time to reconsider the design, and I think maybe I can try to make this a little detailed and see if I'm thinking this issue right. And there are three issues in my today's sharing, and the first is a review of the overall architecture of the greatest level replication that we concluded from previous CDMs, and then I think we can go into some details of the implementation. I'll try to I'll try to talk about this in two separate parts. The first is main cluster implementation, and the second is backup cluster implementation. Now the first part is the first section is the overall architecture. As the previous as discussed in previous CDMs, I think maybe the overall architecture of Redis level replication can be like this. Generally speaking, there are two separate procedures in this whole replication. First is for monitors to schedule all the pauses for the OSD's ops processing, and the other is the OSDs to keep replicating their operations from the master cluster to the backup cluster. And when we think about the implementation of this architecture, we think there should be the following principles. The first is we should modify the current system as less as possible, and reduce the current system's components as much as possible. And the second is we should make as little impact on the performance of the system components as possible. So the next section is the master cluster implementation. First, we think that the operations that issue to the main Redis cluster can be classified into two categories. The first is that those ops issued by the client. We'll call it liberated ops, and the other is ops was issued by other OSDs, like replicas. And we think that only liberated ops, that's ops issued by clients that need to be replicated. We think that the main difficulty is that when implementing the replication mechanism in the main cluster part are the following. The first is we have to deal with various situations that replication cannot go on. For example, if the backup cluster is full, then we have to suspend the replication until there are more spaces, and there are more spaces in the backup cluster. And the second is we have to preserve the ops replication order when the OSD map changes. And we think that for the second difficulty, we think we can accomplish it by first making sure replication journal entries for the ops needing to be replicated are considered removable only when the corresponding replication is finished. And during the recovery backfill phase, making sure an object gets recovered only when all liberated ops targeting it gets replicated. We think if we can make sure these 2 points, then we can preserve the replication order when OSD map changes. To deal with the first difficulty, we think we should first first think about under what circumstances that replication needs to suspend. And we think there are the following scenarios that replication needs to suspend. The first is if there are enough OSDs whose replication of cache is full, then the replication of ops targeting that PG should be suspended. By this we mean that, for example, if all the OSDs holding a PG is the replication ops cache of all the OSDs of holding a PG is full, then the replication for ops targeting that PG should be suspended. And in the meantime, monitors should suspend sending out snapshot notifications. And also, if the backup cluster is for replication full, then we also have to suspend the replication. Another problem, another thing that we have to consider is maybe the replication can go on, but the snapshot notification should be suspended. And for example, if if the system clocks of all OSDs in a PG's acting set are out of sync, then the snapshot notification should be suspended. And by replication ops cache, we mean that since we have to replicate liberated ops, then we have to make a cache for those ops that are not replicated yet. And we think that maybe we can reuse the existing file journal by adding some additional pointers into it. And we think we can change the file journal like this. We can add 2 pointers. The first is OP replication head, and the second is OP replication tail. They point to the range, the 2 ends of the range that holds the liberated ops that needs to be replicated, and only journal entries outside the set, outside this set, can be considered removable, and that means if the ops are not replicated yet, then it cannot be removed from the file journal, and when filling the file journal, and we must use the space outside of this range. Also, since not all the ops needs to be replicated, for example, perhaps the replicas that issued by other OSDs, and we think that maybe we should add a new flag into the file journal entry. We name it need replicate, indicating that the OP needs to be replicated. And the basic idea of our replication is that we think maybe we can let the users specify which objects what hops can be should be replicated and what hops are not. So we think we need to add a new flag, need replicate in the object infer, indicating whether ops targeting this object need to be replicated. And this is set by clients. And we also need another flag, need full replication, indicating whether there are ops targeting this object, but not replicated because of those replication suspend conditions. And we think we should introduce a new module, replication worker. The main purpose of this module is to keep replicating liberated ops to the backup cluster, and conceptually it should be comprised of a cache used to store ops that need to be replicated, and a working thread that continuously replicate those ops targeting PGs of which the current OSD is acting primary, and the replication worker should remove ops when those ops are replicated, and by replicated we mean that the commit message is received from OSDs in the backup cluster, or a can remove message is received from the PGs are acting primary, and by removing ops, replication worker can move forward the journal's pointer, and which is this pointer, OPU replication tail. And also, when an op is replicated, the replication worker should also send a can remove message to replica OSDs of the targeting PG. Now, another thing we have to consider is replication robustness, and by that we mean that sorry, I don't know. Till now, am I making myself clear or not?
Yeah, I think you're being pretty clear. I guess I had some questions regarding the some of the details there. So when you're talking about the snapshot piece, how are you thinking of bounding that time and then doing that snapshot?
I'm sorry, I didn't hear it clearly.
You'd mentioned that in the original diagram of the architecture that you're talking about a time bound for snapshots.
Do you mean this graph?
Yeah. So the T bound there. How are you coordinating those time bounds?
Sorry, wait a second. I think I can. Do you mean how do I determine the time bound, right?
Right.
This is the previous document. First, we have to specify a time slice that will or a snapshot duration, and the monitor set the time bound according to its current system time, and plus the snapshot duration. And since we assume that all OSDs and monitors are synced with the same time synchronization server, then they should be the time bound should make sense for all the OSDs, and OSDs can make their future pause time to T-bound subtract their local time. I don't know if I'm making this clear.
Yeah, I think that makes sense now. Thanks for the extra context I had forgotten from the previous document. So, so basically your snapshots end up being then based on the error of the clocks and network latency there.
Yeah. Yes. Yes. That's why I'll in the last section that we're planning on adding extra methods to calculate hot error bound to a Crony, which we intend to use as as our time synchronization tool. Sorry, did I misunderstand you?
I know that makes sense. So when you're talking about using the piece of the journal as the ops cache, and not removing things from it once that becomes full. So that means that when the if replication stops for some reason or needs to be suspended, you're talking about clearing that cache out and letting operations in the main cluster continue while marking the objects as needing complete replication later.
Yeah, yes. Oh, sorry, I didn't understand you. Could you speak more slowly, please? Thank you.
Sure, sorry.
Sorry.
So I guess I'm wondering, with that design, how is the replication worker going to find the objects that need to be fully replicated after I suspend?
Oh yeah, I got what you mean. That's what I'm about to talk about. This, we think that maybe we need to add a new field in PG-Infer, need full replication set. We think a boom filter should be appropriate for this target, for this purpose, and we can use a boom filter to store. When the liberator ops comes, when the liberator op come, OP count, and it cannot get replicated because of those replication suspend condition, then we can add the object ID into this set, and later when the replication suspend condition is cleared, then the replication worker can use information in this set to continue to do full replication of those objects that had ops targeting it not replicated. I don't know if I'm making myself clear.
Yeah, I think that makes sense. So you'd end up listing off through all the objects and checking that Bloom filter to see whether they needed full replication or not.
Yes. Yeah. And sorry, I forget this.
So I guess I'm wondering if that's going to be an issue with when you have too many objects for the replication worker to catch up in the replication before the cluster gets more I/O that it needs to continue replicating. That is, after like a long suspend period, it has to go through all, too many objects to replicate, and can't keep up with the other changes.
I think we can actually we didn't consider this problem, but I think we can if the replication is suspended for too long, and we think when the replication worker gets to replicate I can make this now. I think I'll mark your problem, and I'll consider it later.
Sure.
Sorry, I can think clearly on this.
Yeah, I guess it's analogous to trying to enable replication in this sense on a pool of existing objects that also have I/O against them.
Yeah, yes, that definitely should be considered, and we just missed it. And I think we'll consider this later.
Sure.
Thank you.
Maybe Jason, maybe you have some thoughts about this, since it's kind of analogous to what RBD mirroring does.
Is it though? I mean,
Well, in terms of the full versus partial replication. I guess the major difference there is that the replication daemon for RBD can make progress on other objects and without blocking on one subset. If one image needs to be like fully replicated.
Yeah. It's certainly a hard problem.
So I think maybe I can go on now.
Sure.
Or
Sounds good.
I don't know if I'm occupying too much time. I don't know.
We still got
Okay.
plenty of time, so please continue.
So that, well, thank you for your time. So next we will, I think maybe we should talk about the replication robustness. I think the following circumstance should be considered if all OSD's replication cache for the PG is full, then there are liberators ops that are not replicated yet, and at this time, if some OSD goes down or all OSDs of the PG goes down, those liberators ops should not be lost. So we think we can solve this problem in this way. First, we need a new configuration item, replication mean size. That is the least number of OSDs that should hold the replicas of liberator ops while the replication is not completed yet. This mean size thing is similar to current pool's mean size.
Why would that be different from the current pool's min size?
Sorry?
Why would that be different from the current pool min size property?
We think that actually we think that I guess it should be the same. I think I just misconsider this item. I think they should be the same.
Okay.
Sorry.
Yeah, no worries.
I don't know what I was
the point
thinking.
is that the replication worker should consider it, though, I guess.
Yeah.
The replication worker should not operate when the PG is below min size.
Yes, that makes sense. Sorry, I don't know what I was thinking when I was considering this problem.
That's okay.
Sorry. Okay. The next. I think replica OSDs should encapsulate flag indicating whether OP replication tail is moved forward by a rep OP in reply to that. In reply to that rep OP, this would make the acting primary aware of their current aware of their current replication cache space, and if less than this mean size OSDs has moved forward their replication tail, then the PG should be marked as replication full, and all subsequent liberators ops can be replicated until this mark is clear. And when an OSD's replication ops cache is left with enough space, a message should be sent to all acting primaries. I'm sorry, I spell this word. the message should be sent to all acting primaries who has a common PG with this OSD. And when OSD is capable of caching liberated stops for replication are enough, then the PG's replication full mark is clear. And for the purpose of better performance, we think that acting primary doesn't need to wait for the replica reply. We can simply just mark all the target objects as need full replication first, and then clear this mark when the liberated SOP is replicated. And when a liberated SOP replication is done, the replication executing OSD should send out replication succeeded message for that OP to other OSDs in the acting set, and this would make those OSDs clear the need full replication mark.
Okay, so it's essentially like a two-phase commit to manage the replication space.
Yes. It's like that. It's like two-phase commit. Sorry.
I think that makes sense in the common case. I think it might get into some trouble with integrating that into the peering process, since essentially during peering, if we have some operations that were divergent, e.g. applied to some replicas and not others, that we haven't entirely completed yet, we need to like roll them back or discard them in the case of erasure coded pools.
I'll record this. I'll record your.
So maybe make a note that we'll need to be careful about that aspect of it.
Yeah. We didn't think about this. Okay. And the last thing is there can be circumstances that the acting primary has its replication ops cache full, and then the new OSD should be selected for the replication work. And so this decision can be made by acting primary, and we think it can just select the second. It can just select the first OSD that has enough replication ops cache in the acting set. Sorry. I think that in this way, this problem should be solved. And we did consider the peering process a little, and we think that by the time we were considering this, we think that the only thing that needs to be modified in the peering recovery backfill procedure is that an object's recovery source should replicate all liberated ops before pushing that object. But we didn't consider those divergent operations. I think we'll consider that later.
Yeah, makes sense. I guess I'd be a little bit worried about having the replicas coordinate the replication instead of having the primary do it, simply because the primary is the general coordinator of other activity. So there might be some structures that aren't necessarily up to date on the replicas.
I'm sorry, could you speak a little slower, please?
So on your last point in the previous slide, with trying to delegate the responsibility for replication to the replicas instead of having the primary do it.
Yeah,
I'd just be a
yes.
little bit worried about that. In case you accidentally relied on some bit of state that wasn't properly kept in sync with the primary. That is, like currently with like most of the background operations, they're all controlled by the primary, so it has like full knowledge of what's going on. You just might run into some issues there.
Okay. I got your point.
I don't think it's not. I think it's possible to do it this way, but it might be more difficult.
Okay. Well, there are a lot of things to think. Okay, I've recorded your question. Okay. And the last part of my sharing is the backup clustering implementation, and we think the main problem for this part of replication is that we have to make sure efficient replication ops caching and efficient recovery when OSD map changes. To make efficient rep ops caching, maybe we think it could be simple. We just append replication ops to replication ops cache. Then this procedure should be very efficient. But when considering the recovery or backfill phase, when OSD map changes, to make that process efficient and at the same time maintaining efficient replication ops caching could be a little tricky. So we think that we can add an additional processing step for replication OP processing between ops journaling and ops applying. We call it RAL ops storing. And then in this phase, we store the 3-tuple timestamp, object ID, and operation in RocksDB. And we think that this should make the recovery phase to be efficient, since the query of RocksDB could make the process more quickly. And also ops applying happens when the backup cluster monitor receives a snapshot notification that tells replication ops earlier than a certain time point can be merged into the backend store. And one thing to note is only replication ops need the RAW ops storing phase. Other ops like those ops caused by recovery and backfill does not need the RAW OP storing phase. And also to make the applying to make the ops applying more efficient, we think that there should be a new thread that keeps feeding the file stores OP work queue with replication ops stored in the RocksDB that is in RAW ops storing phase. And the current file stores working thread pool should also distinguish the processing of replication ops and other ops, since replication ops can only be applied when the corresponding snapshot notification is received. And also replication ops targeting the same object maybe should be merged to the greatest extent before applied to the underlying object, which we think could make the applying phase more efficient and make the whole replication more efficient. Because we think the applying phase in the backup cluster could be the final bottleneck of the whole replication mechanism. This is my last part. Am I making myself clear?
Yeah, I think so. So I'm just a little confused when you were talking about the replication ops there. You're just meaning we're only storing the those in the local cluster for immediate replication, or in the backup cluster, and then having the backup cluster apply from that extra replication log. So that is like restating that you're talking about storing these replication ops in a log in RocksDB on the backup cluster.
I'm sorry, I didn't hear clearly.
So I guess I'm asking, are the replication ops that you're talking about storing in the backup cluster itself? Or are they in the main cluster?
Oh, I think there should be by replication ops. I mean those ops that's issued by the main cluster to the backup cluster.
Okay.
That needs to be replicated. Yeah. I don't know if I'm not.
Yeah, that makes sense now.
Sorry. I'm sorry. Yes, and so we think only those ops that needs to be replicated should be stored in the RocksDB in the raw ops storing phase, and also if OSD map changes, then all the replication ops targeting some object should be recovered together with that object, and those replication ops should also be stored in the RocksDB of the new OSD. I don't know if I'm saying this correctly.
Yeah, that makes sense.
And then about the last part, do you have other things that you worry about?
Well, I guess one worry would be is that storing them in RocksDB might not be ideal if the bottleneck is CPU or write throughput, since RocksDB tends to have quite a bit of write amplification.
Yeah. Then I don't know. This storing replication ops in RocksDB also worries me. But do you have any suggestions that how this can be done efficiently?
I guess another option would be using whatever backing store, like file store or blue store, to store them in lighter chunks that don't have the same kind of write amplification that RocksDB would.
Okay. I'll
but that's not really It's not really a flaw in the design. That's just a kind of detail of the implementation.
Okay. Sorry, I didn't hear you clearly.
I'm saying that it's not really a flaw in the design. It's just a detail of the implementation where you're storing those. So
Yeah.
I guess I'm just suggesting maybe abstracting out that storage detail. So that you could put it in RocksDB, or if you find that that is a bottleneck, put it somewhere else later.
Okay. That's your point. Okay. Do you have any other questions?
Not at the moment. I think this is very interesting, though. It's more fully fleshed out now, so it's looking like it may work pretty well. I guess I think one of the bits that depends on this is, of course, how hard the time bounds can get, how low the time bounds can get, which you mentioned earlier. You're going to look at more.
Okay. Well, I don't know. Maybe we can talk about this in the mailing list. I think
Yeah.
It's a little difficult for me to discuss this at the time.
Sure. Thank you very much for this update. I think it's very promising, and it's great to see more of these details filled in.
Thank you for saying that. I just don't want to occupy too much time. Sorry.
No problem.
Okay. Yeah, I guess that's all for me now. Thank you.
Okay. Thank you. So I think that was the last topic that we had that didn't have Sage required for it, and I don't see Sage around yet. So, did anybody else have any other topics they wanted to bring up?
Well, I guess we can talk a bit about the Messenger too.
Sure.
Just a quick update on the current status. Yeah, so basically we started the implementation work of the Messenger v2, which was designed a few months ago. Well, half a year now. Half a year now. Yeah. During the implementation phase, we are also changing a bit the initial design, especially in the authentication phase. And I think I don't know if I already posted. I think I have in Ceph devel a link to a branch where the implementation resides. And I also opened the pull request with changes to the documentation of the design documentation of Messenger v2. I'm going to paste the link in the chat for the design document with the latest changes. Yeah, so I've been talking with Sage, and there's this. We still didn't know how the
so the messenger to one of the new features is the possibility to have encryption on the wire support. And we have been discussing how this can be implemented. If the encryption mechanism should be implemented by us using some library with support for several cipher algorithms, or if this should be somehow outsourced completely to other library. And I think the path that we are going to take is to for all these authentication and encryption is to use an API, a standard API called GSS API. I don't clearly remember get the name. Yeah. So the path we should take is to use the GSS APIs, which already have implementations with several authentication backends like Kerberos and others. And the idea is to basically implement our auth. So we give an implementation of our auth interface that calls these GSS APIs. So that's the idea. For instance, currently in Ceph, we only have one implementation of the auth interface, which is Cephx. Well, we also have the non-authentication implementation, of course, but that's the trivial one. Yeah, so that's the current status, basically.
This is Daniel. I can also add a little bit about the GSS APIs part of the thing.
Sure.
So there are a few things. I've been talking to Sage as well, and let me just pass this one here. This is the branch where we're keeping all the Kerberos and LDAP changes we're going to be working on. So I'm in the process of refactoring that. After talking to Sage, it was decided that what we need to focus on right now is the Kerberos part of it, not the LDAP. So we know that LDAP will be needed, but at least for now, for Mimic, what we want to focus on is the Kerberos part of it. So for Kerberos, we are using GSS APIs, and that's what we're using to request a token from a Kerberos KDC. And from that one token is where the authentication is going to go through the monitors, OSDs, and all that part of things. So hopefully get the refactoring that I need to get done this week. So then I can start tackling again the authentication issues on the node sides of the things. But that's where we're tracking all the work done. As far as LDAP and Kerberos. LDAP will just leave it for now the way it is, the code the way it is. Not touch it much because, again, Sage mentioned that we should focus on Kerberos for now. But then once that is all done and stable, then we'll go back to LDAP and make sure that both of them are working as they're supposed to.
Thanks. Was the idea there? Can you give us a little more background regarding the Kerberos bit then? Is the idea there to use Kerberos to authenticate only clients, or also to use it for inter-cluster authentication?
My understanding is that eventually we're going to cover all the scenarios. So there's a scenario where the nodes will be configured to ask a KDC for a Kerberos token. And with that, we would use that in place of Ceph. There's also the requirement that we do the same for users. So users should be able to request a token, and once he has that one token, he's authenticated. We would use a single sign-on so he could access the cluster resources that he's been assigned to. But for now, according to our last talk, what we want to focus on is to make sure that first the monitor is able to do that, at least the monitor for now. And if we get to the point where a user could request a token and then be authenticated with that, that would be perfect. But for now, the main thing is get the nodes, especially the monitor, to work well. Because Sage was talking about there's a whole lot of things that he's seen in the actual design that we're expecting to have a whole lot of crashes, and that's why we want to tackle that first, see how bad that's going to be. And then how much code and or refactoring going to need to do for that. Then after that, we're going to tackle the other sides of the things.
Okay, thanks. Yeah, that makes sense. All right. Any other questions regarding Messenger 2 or Kerberos? Okay. Thanks, Ricardo and Daniel.
No problem.
I think that's all the topics we have for today. So thanks everybody for joining, and we'll talk to you next month.
Thank you.
Thanks. Bye.